Okay, 6-7, solving radical equations. And we ride! Alright, 3-step process. Yes, oh gosh, yes. 3-step process. Number 1, isolate the radical on one side of the equation. These are going to have square roots, or cube roots, or fourth roots. Alright, so that's why it says isolate the radical. Maybe more than one radical, but you just have to isolate one of the radicals on one of the sides of the equations. Everybody catch that train? Okay. You might have multiple square roots, you might not. You just gotta get one by itself. Alright. Step 2. Raise each side of the equation to a power equal to the index of the radical to eliminate the radical. Raise each side of the equation to a power equal to the index of the radical to eliminate the radical. For example, a square root cancels out what? A square root will undo a... Nope. A square root will undo a what? A square power. Exactly, okay? A square power. A cube root will undo a cube power. A fourth root will undo a fourth power. Flip it now. A square will undo a square root. A cube power will undo a cube root. A fourth power will undo a fourth root. That's what this guy's talking about right here. Okay? Raise each side of the equation to a power equal to the index of the radical to eliminate it. Okay. Step 3. Solve the resulting polynomial equation. Check your results. You got to check these. Okay, you can't get around not checking them. So the first example here, we have the square root of x plus 2 plus 4 equals 7. So the first thing we need to do is to isolate the square root, which is our radical here. So how are we going to do that? How are we going to get that by itself? How are we going to get this square root by itself?
Put it on the other side?
No. Subtract what? Subtract 4.
Yeah.
Okay, so the square root of x plus 2 equals 3. Okay, now what? Square both sides. Okay, since it's a square root, you want to do a square power. So you square the left side, you square the right side. So square root cancels out. On the left side, you're left with just x plus 2. On the right side, you're left with 3 squared, which is 9. Last step, to solve for x, subtract 2. In there. So to check these, you have the square root of 7 plus 2 plus 4 on the outside of the radical equals 7. Can't see the yellow. I wish I could just highlight it in color and change it. That'd be sweet.
Sorry.
It's okay. Alright, and from there you go and simplify. So 7 plus 2 gives you 9.
Wow, why did it stop? Okay.
Square root of 9 is? 3. 3 plus 4 equals 7. Is that true? Yeah. So 7 works. Alright. Alright, next one. We got the square root of the big quantity x minus 12 equals 2 minus the square root of x.
Wait, so you have to write down the extra stuff you wrote down? Huh?
You don't have to,
Oh, I got you.
but you have to still do it in your head or something. But you don't have to write it down. Okay? Now, the first steps directions, they're actually fairly clear, but you can kind of misinterpret them a little bit. Okay? It says isolate a radical on one side of the equation. Okay? It does not say isolate the radicals to one side. All right? So all you need is one radical isolated, which we have right here. So we're actually already done. Okay? With that first step. See that? We have one radical isolated to one side of the equation. All right? Now, your next step is what? No?
Subtract.
Nope.
12. Add 12.
Square them.
Will you square both?
Yes. You square both sides. And what's the right-hand side? The right-hand side is what in the original? 2 minus x. You square that. And when you square that binomial, you what? Mm-hmm. You got a what? Nope. Foil. Okay. So left side becomes just x minus 12 equals left side, right side foiled out now. 2 times 2 gives you 4. 2 times the negative square root of x gives you negative 2 square root x. Negative rad x times 2 gives you negative 2 square root of x. Negative times negative gives you positive. Square root of x gives you square root of x squared, which is just x. Just x. What do you see here in between? Like terms, so let's combine those real quick. So x minus 12 equals 4 minus 4 times the square root of x plus x. Okay. Now, notice how step 3, what does step 3 say? Solve the resulting polynomial equation. Polynomial is a generic term, which means that the equation that pops out of this could be anything. Chances are it'll be one of two. It'll either be linear or it'll be radical. Last one was linear. Since this one has a square root in it, it is radical. So basically what you have to do is you have to go through all those steps again. You have to start from the beginning. Isolate your radical, raise it to a power, check your equation. All right? So, first thing you should see is there's x's on both sides. They what? They cancel out because you just subtract x from both sides, right? So negative 12 equals 4 minus 4 times the square root of x. Okay, what's your next step from here? Subtract 4. So negative 12 minus 4 gives you negative 16, which equals negative 4 square root of x. Your next step is to divide by, because it's multiply right there, right? So it gives you 4 equals the square root of x, and then you square it. You have the radical isolated, so now you square it. So you get x equals 16. Oh. A lot of work for that. Now, what's the last 3 words in your directions? Check it. Okay, so here's me checking. Ready? Square root of 16 minus 12 better equal 2 minus the square root of 16. Okay, if this comes up true, we good. What's 16 minus 12 on the left hand? 4. What's the square root of 4? 2. So the left hand side is 2, right? What's square root of 16 here? 4. So we get 2 minus 4. What's 2 minus 4? Negative 2. Is that equal? Nope. So is 16 an answer? Nah. So then what is the answer? Nope. 16 didn't work. Your answer is no solution. And which is weird, ain't it?
Yeah.
I'm sitting here telling you that everything we did on this left-hand column is good. Algebra is beautiful. It's great. You did nothing wrong. But yet, you get an answer that doesn't work. Okay? That can happen.
So that's how you're going to figure out if you did it right or not.
Right.
So we do have to use.
Yes. You have to check these. Okay? Now, real quick. Does everybody have that wrote down?
Yeah.
Okay. Remember back in chapter 3, we had things like 3x plus 2y equals 12, and I don't know, 4x minus 6y equals 2. Sure, whatever. Remember what that's called? Does anybody know what that's called? 3 words, starts with an S. System of equations. Okay. And when we had a system of equations, the answer was a point where they what? Yeah, intersect. Okay. The solution to these two is right there. See that? Where they two cross. It's an ugly intersection, but an intersection nonetheless. It's where the two cross. Okay. Now, the left side was what? Square root of x minus 12. Is that right?
Yeah.
And the right side was 2 minus the square root of x. Yes?
Looks good.
Wasn't
That's
it?
bad.
It just stops.
Mm-hmm.
Teachers, pardon the interruption. The soccer team will be dismissed at 2:30.
Okay. Now, if you look at these two graphs, they are kind of weird because they have a starting point, and then they go. Notice how the green graph, he like stops here, or technically starts there. Okay, but he doesn't keep going this way. So between these two, there's no what?
Intersection.
There's no intersection of the two lines, right? Therefore, there's going to be no solution. Okay? Now, just because, now, I'm going to say this, and you guys are going to be like, but you said, I'm going to be like, but you weren't listening. Most cases, okay, your no solutions will show up more often when you have to FOIL a side. Okay? But I'm going to go back to here and show you that it's not always the case. Because what if I made this, I think I made this 6 last hour. Yeah. Because then look. Now they intersect. Now it works. Okay? So it's more often than not when you have to FOIL, but it's not every time you FOIL. Make sense? Okay, so that's why it's definitely important to check these. Okay, everybody good? All right, now the next one. Fractions. Ew. Anyways, you're going to take this guy the exact same way, though. Okay. So think about the correlation between the two. Think about what your first step would be. Okay, from on one where it was root. Now think about what it would be here. What do you think your first step is? Plus 4. Okay, you add 4. So you get 2 parentheses, 6x minus 3 to the 1/3 power equals 4. What's your next step? No.
No, the one
No.
there. No.
No, Almeida. No, not yet. Slaughter.
Would you multiply 1/3 by 1/3?
No.
No.
Nope. You guys are getting ahead of yourselves.
Would you? This is squared.
No.
I'm thinking about it too much.
Divide by 2.
Did you get it?
Divide by 2. Okay. Because then the left 2 and the 2 here and the 2 here, whoop, whoop, they're gone. And that's the thing. You are isolating the part that you're going to take to the power. Okay, you're isolating this guy.
So, if that was a 3, you would put 3.
Upper parentheses 6x minus 3 plus 1 times 1/3.
2 to the 1/3. It's a power.
1/3. Oh, equals 2.
Equals 2. Yep.
Wait, so you don't divide the inside?
Nope. Just the outside. Okay. Now, we have the part that's acting as a radical isolated. See that? It's by itself. We are now going to take it to a power such that it cancels out the 1/3. So what power should we take it to cancel out the 1/3 Jordan.
The 1/3 power.
No.
No?
The third power. Take it to the third. Okay?
Okay.
See now? Because right here, you see this right here? You have 1/3 to the third, which is power of power. When you have power of a power right there, you do what with those powers?
What's that?
Right there, you do what? You multiply. And 3 times 1/3, if that looks like a 3, is 1. That's the goal. Okay? So your left-hand side becomes 6x minus 3. Your right-hand side becomes what? 8. What's your next step? Add 3. So 6x equals 11, and then you divide by 6. So x equals 11/6. Step 1. Add 2. Which gives you 3. 5y minus 1 to the 1/3 power equals 2. Step 2. Divide by 3. The 3's cancel, which leaves you with 5y minus 1, still to the 1/3 power, equals 2/3. Everybody good? Okay. Next step. Cube everything, which leaves you with 5y minus 1. 2 times 2 times 2 gives you 8. 3 times 3 times 3 gives you 27. 2/3 times 2/3 times 2/3. Multiply your numerators, multiply your denominators. Okay? Next step. What do you do next? You add 1. You don't care if say 27 on the other side, who gives a crap? You add 1. Plus 1. Plus 1. Okay? Now, in order to add fractions, they need to have what? Common denominators. The denominator on 8/27 is 27. The denominator on 1 is 1. So we need to rewrite 1 to have a denominator of 27. How do you rewrite 1 with a denominator of 27? 27 over 27. 27 27ths. Next question. How do you add fractions together?
You just add the numerator.
What happens to the denominators?
Stay the same.
They stay the same. So what's 8 plus 27?
35.
35. I'm going to go up top now, okay? So you get 5y equals 35 27.
That's 11 numbers.
What's your next step? Divide by 5. Now, say it a different way. Instead of dividing by 5, we could multiply by what? Instead of dividing by 5, you could multiply by,
5 more 1.
try again, 1/5. Because then what's going to happen to these two 5s? They're canceling.
Don't the 1's cancel too?
Well, sure. But it's just one, right? Okay. Left side gives you y equals 35 27ths times 1/5. What happens here?
Divide.
By
5.
5. So 5 goes into 35 how many times? 7. So what's your final answer?
7 over 27.
See, you can't tell me you guys are too dumb to handle fractions. Because you're not!
It could be worse.
Okay?
Your guidance, anything is possible.
Not anything is possible. You can't
Yeah.
run. You can't run to the moon.
Certainly can.
Homework for the set is page 432, 1 through 12, and number 35.